Okay, so here comes part number 2 of the tutorial on how to make your engine step by step. But before we could proceed to running the in-game numbers, I need to cover the two theories that we have going on at the moment. Indicated horsepower versus brake horsepower. We do not know which one NASCAR 2003 uses, so we don't know if we are using the indicated mean effective pressures or we are using brake mean effective pressures. That is what I want to cover in this video. The indicated horsepower is a horsepower calculated by a special device that is installed inside the cylinder. Let's just say we install a little chip right here, for example, next to the spark plug. I'm not exactly sure where it is installed, but I would assume this would be a good spot. And at the moment of the explosion, at the moment of the bang, this little device tells you we got 200 psi of pressure in the cylinder when it has just exploded. Boom! And that is indicated mean effective pressure, because it is measured by a device called indicator right here that's installed in the cylinder. Now let me just briefly cover up all the processes that go within the engine quickly. On the induction cycle, we are sucking the air and fuel mixture in. That requires energy, right? Minus. That means that we just wasted some energy sucking in the air-fuel mixture. On top of driving the piston down to do that. Driving the piston down right here also requires energy. On the second stroke, we're starting to compress the air-fuel mixture that we have. All the little fuel and air particles right here that we got, we're starting to compress them. And that brings us to the compression stroke, where we lose the energy to compress the mixture that is right here, and as well as we're losing energy to drive the piston upwards. Like the piston itself has its weight, it has its qualities, the gravity is acting on it, so that is another, we're losing energy here, 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 and here, all the way up to the point of explosion. And in the green values we got energy plus, big boost of energy right here when the explosion happens. This explosion compensates for all of our losses and then some to drive the car, and that will drive our piston down. To do that, we're spending energy, but also on the power stroke we have energy plus, energy delivered to the crankshaft, to the transmission, and to the wheels. So the size of this bang right here in blue is big enough to cover up for all of our losses. Then the last cycle would be the exhaust cycle, where we are getting rid of our charge that just produced the explosion, and that also requires small energy loss to pump the gases out, and then as well as energy loss to drive the piston upwards, or just keep the engine rotating, let's put it this way. Now the blue point right here that I drew, the size of our explosion, is our indicated measurements. That is before any of the energy losses right here take place. Now let's talk about brake horsepower. And brake horsepower is the horsepower that is left to drive the car after all this stuff is lost. After we spend time on pumping the gases, after we spend time on moving the pistons. And let me talk about the biggest energy thief, so to say, and that would be friction and heat. We are producing so much heat and so much friction right here when this thing explodes that most of the engine power, most of the chemical power of the explosion gets lost to the heat and friction. Some of it gets lost to the pumping of the air and pumping it in and pumping it out, but heat and friction are a lot of our, so to say, energy losses. Also, rotating motion. To keep the engine rotating, it takes a lot of energy because they all have weight. All the pistons, all the parts have weight, and the faster you want to spin the piston, the less time you have for it to go up and down, and the more mean piston speed that you're gonna experience. We're gonna talk about that later. Let me put it in big letters right here. Mean piston speed. That's for later. That is testing our mechanical qualities of our engine. If you have weak parts and crappy metal, mean piston speed is what's gonna break your engine pretty quick. You're just gonna break your parts going up and down too fast. Now let me cover up the brake horsepower. Let me talk about brake horsepower a little bit. That is for now. Let's say we have our indicated horsepower minus what? That is what is very important right here. Minus energy losses. Kind of disappeared for a second. And that would equal our brake horsepower. That is the deal that is driving our engine, how much power we actually have to use. And here comes our theory for NASCAR for later, for the next video. Are we going to be using indicated horsepower? Because we don't know what NASCAR uses. Or are we going to be using brake horsepower? In respect to that, actually, once again, are we going to be using brake mean effective pressures, BMEPs, or are we going to be using indicated mean effective pressures, IMEPs? The formula for them is the same, but rather the numeric value is going to be higher for the indicated horsepower. I don't know if I have confused you too much, but if you look at all of this, basically what we're dealing with, to summarize it, is the size of the bang right here, boom, right? The energy losses that gets lost during the process of making that happen, and then the last part is how much power we actually have right here, brake horsepower, that is left to drive our engine. I'm gonna stop right here. In the second part of the video, if I still have time, I will show you the torque curve and two different points on the torque curve which indicate two different power ratings. Okay, in this part I have 6 more minutes to finish up. I have a basic torque curve on the right and mean effective pressure summary diagram on the left. We have already talked about indicated pressures and brake mean effective pressures. Now the indicated pressure, once again, is the one that's created inside the cylinder when the explosion happens. Boom! Then we have to deal with two types of losses. I call them energy losses, but you could split them in two. Pumping losses, the ones that are required to pump the air and fuel in and exhaust out, and friction losses, basically heat, cylinder wear, friction, everything else pretty much. And then once those two are subtracted from the indicated pressure, the pressure that finally reaches the crankshaft as the usable pressure is the brake mean effective pressure. Basically we have a theory number 1 that NASCAR 2003 might be running these pressures, and theory number 2 that I might be running the brake mean effective pressures as its numbers for torque 1, 2, 3. Let me rewrite the formula to how we should see and view it as of right now. Indicated horsepower minus pumping would equal the new player, net. That's your net mean effective pressure. That has nothing to do with net horsepower. Indicated horsepower is related to indicated mean effective pressure. Then brake horsepower is related to brake mean effective pressure. But net horsepower has nothing to do with net mean effective pressure. Now I confused you hella hard. I am sure that as of this point you all have no idea what's going on. But anyway, indicated pressure minus pumping pressure equals net pressure. And then the net pressure minus friction pressure would equal your last brake mean effective pressure. Sure, I misspelled that one. Forgive me. Now, that's the guy that we'll be running. And indicated mean effective pressures is another guy that we might be running. These two are bad guys that rob us off of energy. And the net pressure is another theory that we might be running net pressures in NASCAR 2003, which is unlikely, just using my logic, but I'm not sure. This could be two. So we have three possible numbers that our game could be running. These ones, net effective pressures or brake mean effective pressures. One of those three is what the NASCAR 2003 uses for its horsepower calculation. What else? Let me just underline them one more time right here. We either gonna be running these numbers, or brake mean effective pressures. One of those three is what NASCAR 2003 uses. And we're gonna do our testing. I myself do not know which ones it uses, so that's the aim of the whole video series, to figure it out and finally make an engine for someone. I'm gonna kill the video right here. Hope I fit in 15 minutes. And stay tuned for one more. Part 2 is coming up, and I will cover the torque curve, and from there we will finally go in the game.